Hello, friends, and welcome to the Snoozy Scientist. I'm really glad you found your way here tonight. Wherever in the world you're watching from, this little corner of calm was specially made just for you. A gentle space where science can meet stillness and stories can carry you into sleep. Tonight, we're drifting quietly into one of the most dramatic and mysterious days in Earth's entire history. A story not just about extinction, but about the final breathtaking hours before it. Once upon a time, long before humans walked the earth, before cities, before language, even before flowers bloomed, the world belonged to giants. For 150 million years, thunder-footed creatures ruled the land, the skies, and the seas, until one day it all ended. We've all heard the story. A massive asteroid slammed into Earth and wiped out all the dinosaurs. But stories like this are never that simple. What really happened on that day the asteroid hit? Did every dinosaur vanish in an instant? Or did some survive the first blast? What did they see in those last terrifying moments? And what did they feel? Tonight, we'll slowly rewind time to the final sunset dinosaurs would ever see. We'll hear the forests before they burned. We'll feel the weight of the silence before the skies turned black. And we'll walk beside the last of the dinosaurs as they watch their world unravel. If this peaceful little journey is already soothing your mind, it would mean so much if you softly tapped the like button and subscribed. It helps this sleepy channel grow and tells the algorithm that sleep and science actually do get along quite nicely. And if you're feeling cozy, let me know in the comments. Where are you watching from tonight, and what time is it there? It's always great to see how far this little sleepy corner of science reaches. So now, close your eyes, take a deep breath, let your thoughts grow soft, and together, let's relive the final 24 hours of the most powerful creatures Earth has ever known. It was the late Cretaceous period, roughly 66 million years ago, and Earth looked very different than it does today. The continents were still drifting, not yet locked into the familiar puzzle pieces of modern geography. Much of what would one day become North America was split by a shallow inland sea, stretching from the Gulf of Mexico to the Arctic Ocean. Warm waters lapped across lush coastlines. Coral reefs blossomed near the shores. Inland, thick forests covered vast stretches of land, pulsing with green, teeming with life. The global climate was warm, much warmer than today. There were no polar ice caps, sea levels were high, and much of the land now above water was still submerged. Humidity hung thick in the air across the tropics, and even the polar regions, though cooler, were mild enough to support thriving ecosystems. Rain was common, feeding swamps and river basins that gave rise to dense vegetation. Volcanic activity rumbled deep within Earth's crust, especially in regions like what we now call India. But even this was part of a balanced system. The atmosphere was rich in oxygen, plants grew tall and fast, food was everywhere. It was, by all appearances, a golden age of biodiversity. From the skies to the oceans, life had evolved into its most extravagant forms. In the air, flying reptiles soared. Pterosaurs of many shapes and sizes glided over coastlines and forests. Some had wingspans that rivaled fighter jets. Others were smaller and more agile, nesting in cliffs or darting through canyons like birds. Insects buzzed through the ferns, some as large as a human hand, their wings shimmering with color. Below, on land, the dinosaurs ruled. Every ecosystem on Earth had its giants. In the forests and plains roamed towering sauropods with long necks that swayed like cranes as they reached for high leaves. Herds of hadrosaurs, or duck-billed dinosaurs, moved together in tight, organized groups, mothers guiding their young, heads turning as they called out to one another in low, echoing cries. Among the most dominant were the ceratopsians, horned dinosaurs like Triceratops with broad frills and sharp facial horns. They grazed in herds, chewing through dense vegetation, leaving trails through the undergrowth. Nearby, ankylosaurs, armored like tanks, lumbered through the forest with clubbed tails ready to swing at any threat. And then there were the hunters, in the shadows of the trees or pacing across open clearings. Apex predators stalked the land. The Tyrannosaurus rex, towering nearly 20 feet tall and stretching over 40 feet long, was not only one of the largest carnivores to ever live, it was one of the most powerful. Its jaws could crush bone, its senses were sharp, and it ruled its territory with unmatched dominance. But even T Rex was just one part of a larger web. Across the planet, different continents had evolved their own unique predators. In what is now South America, the massive Giganotosaurus hunted the plains. In Asia, the smaller but intelligent velociraptors worked in packs, stalking prey with strategy and speed. The biodiversity wasn't limited to the giants. Tiny mammals scurried through the underbrush, feathered dinosaurs roosted in trees. Turtles, lizards, frogs, and early birds filled the spaces between. The earth was not empty, it was full, brimming with creatures of every size, shape, and purpose. In rivers, fish darted beneath lily pads. Insects pollinated flowering plants that had only recently begun to evolve. The first blooming flowers were spreading across the planet, changing the color and scent of the air forever. Every continent, every ocean, every sky alive. And it all seemed so stable. From the outside, nothing about Earth looked fragile. The ecosystems were complex but balanced. Predators kept herds in check. Herbivores kept plants trimmed. The climate, while hot, was steady. Life had rebounded from earlier extinction events. It had learned to adapt, to thrive, to fill every niche. It's easy to imagine that this was a planet secure in its own rhythm, but above this vibrant, breathing world, far beyond the clouds, something had already broken that rhythm. A traveler, dark and ancient, had crossed the invisible edge of the solar system. It had no mind, no warning, no destination, only motion, and it was falling fast. Far beyond Earth, past the warmth of the inner planets and the pull of the sun's strongest light, something is moving. It doesn't glow, it doesn't shimmer, it doesn't make a sound. It's just a rock, cold, silent, and dark, drifting through space like a forgotten thought. But this is no ordinary rock. It is massive, almost 10 kilometers wide, shaped by eons of collisions and slow drifting time. Jagged and uneven, its surface is scarred by past impacts. Its core is dense, packed with metal and stone, forged in the chaos of an ancient solar system. For millions of years, this asteroid wandered the distant edges of space, pulled gently by the gravity of passing planets, nudged slightly by invisible forces, until something changed. Maybe it was the subtle tug of Jupiter's enormous gravity, or the passing of another object just close enough to shift its path. Whatever the cause, the asteroid veered inward toward the inner solar system, and now it's falling, accelerating. Its speed builds with every passing second, pulled faster and faster by the sun, more than 40,000 miles per hour, nearly 20 times faster than a rifle bullet. It crosses the orbit of Neptune, then Uranus, then Saturn. It slips silently past Mars. Its surface begins to warm just slightly, but only at the edges. There is no fire, no trail, nothing yet to reveal its presence, and no one is watching. There are no satellites, no telescopes, no radar systems scanning the sky, no early warning alarms. Nothing on Earth knows it's coming. It's the late Cretaceous. There are no humans, no eyes on the sky, and so the planet spins peacefully, as if everything is fine. As the asteroid crosses the final threshold into the inner solar system, it becomes a true intruder, a stranger in a space dominated by quiet stability. The planets continue on their gentle orbits. Venus glows softly near the sun. Mercury burns close to the heat. Earth from a distance looks beautiful and blue, wrapped in clouds and spinning slowly against the dark. And still, the asteroid falls. It is now locked on Earth, its trajectory set, its course unstoppable. The angle is precise. The target is locked, not by intention, but by chance, a kind of cosmic coincidence, or, depending on how you see it, a moment of terrible design. It doesn't twist, it doesn't burn yet. There is no rumble, no storm, no warning light flashing in the sky. It's just moving, silently, invisibly, unforgivably fast. Closer now, closer still. As it nears the Earth, the planet begins to pull harder. Gravity takes over, like a magnet pulling in steel. The asteroid tilts ever so slightly, drawn into a sharper dive. The distance closes rapidly. Within minutes, it will pass through the outermost layers of Earth's atmosphere, and finally, the silence starts to crack. A faint pressure builds ahead of the rock, air molecules smashing into its surface with more and more force. Heat begins to rise, not from friction, but from the violent compression of the air in front of it. The asteroid glows faintly at the edges, just beginning to light, but from the surface, none of this is visible yet. Down below, the jungles are calm. Dinosaurs move through the undergrowth. Pterosaurs glide over quiet coastlines. Ocean waves lap at the shores. Everything continues just as it always has. The planet breathes its steady rhythm, unaware that the countdown has already begun. There is no sound in space, no voice to scream out a warning. The only sign is velocity, motion, momentum that cannot be undone. It is now just moments away from entering the sky, above what will one day be the Yucatán Peninsula in Mexico. Still high above the clouds, it's picking up even more speed. Within seconds, its surface will begin to tear apart. Heat will rise beyond anything this world has ever known. Shock waves will begin to form, even before the rock makes contact. But Earth doesn't flinch, it doesn't brace, it simply waits because it doesn't know. And so the stage is set. A thriving planet, a massive invisible bullet, a moment in time that will tear history in two. From this point on, every second matters. The Earth is quiet. 12 hours remain. Above the forests, the sky glows with soft morning light. Clouds drift lazily overhead, pulled by wind currents that slide over warm oceans and inland seas. Nothing looks out of place. There is no red light in the sky, no vibrations in the ground, just a calm, ordinary day. In the lowland valleys, herds of duck-billed dinosaurs move across open clearings, their calls echoing between the trees. Mothers guide their young carefully through shallow river crossings, while older males graze along the edges, chewing through dense reeds and flowering plants. Their broad, flat beaks pull at the greenery in slow rhythm, and their tails sway like metronomes behind them. A few paces away, a group of juvenile ceratopsians tussle gently in the mud. Their horns are small, still growing. Their frills bob up and down as they play, climbing over each other in clumsy stacks. The adults barely notice. The season has been good. Food is plentiful. The air is warm and rich with moisture. High above, pterosaurs ride invisible waves of heat that rise off the land. Some dive sharply, catching insects mid-air. Others perch on cliff edges, grooming their wings with delicate care. Feathers in some smaller species catch the sunlight and shimmer. From a distance, they almost look like birds. Almost. Near the edge of a forest, a family of small feathered theropods scurries through the underbrush. Their bodies are agile, light and fast. They chase after beetles, pause to inspect moving leaves, then dart again. Their world is close to the ground, filled with shadows and flickers of movement. Every rustle is something to be watched. Not far away, the earth thuds under much heavier steps. A lone Tyrannosaurus rex moves slowly across the open grassland, her head low, nostrils testing the air. She isn't hunting, not yet. She's just passing through, her massive form swaying with each step. Around her, the smaller creatures keep their distance. She pauses by a fallen log, scratches her jaw against the bark, then moves on, silent and sure. Even the king of predators seems unhurried. In the trees, leaves rustle as the wind picks up slightly, but it's nothing new. This time of year always brings warm breezes that slide through the canopy and scatter seeds into the soil. From beneath the ferns, frogs call out to one another in short, sharp croaks. Dragonflies drift across ponds, tracing loops above the still water. Out at sea, the waves roll gently toward wide beaches and ancient mangrove forests. The surface shimmers in the light. Farther offshore, beneath the blue, marine reptiles cut through the depths, their long tails propelling them in silence. Schools of fish move as one, flashing silver in unison. Above, seabirds shriek and dive, cutting into the water with narrow wings. Across the globe, the temperature is steady and warm. Earth's oxygen levels are high, filling the lungs of its creatures with ease. Every breath feeds powerful muscles, strong hearts, and fast metabolisms. Even in the cooler polar regions, life thrives. Herds of smaller dinosaurs travel in groups, moving across conifer-covered slopes under cloudy skies. There is no ice, no winter, just another day in a world that has adapted perfectly to its climate. But deep beneath the ground, in a place now known as India, something else is stirring. Far below the surface, pressure builds in massive chambers of molten rock. For thousands of years, volcanic activity has been increasing, slowly, steadily, with no fanfare. Fissures stretch wider, heat gathers. The Deccan Traps, a vast region of volcanoes and lava fields, sits poised for eruption. The ground here is warm, the air smells faintly of sulfur. Occasionally, small plumes of smoke escape cracks in the crust. But it's nothing new. These eruptions come in waves, and the land has always rebounded. No creature walking above can feel the slow pulse of magma rising. No animal senses the invisible pressure building in the dark. Even here, in a place that hints at chaos, life continues undisturbed. Herds move across blackened fields. Birds build nests in cracks along rock walls. Lizards sun themselves on warm stones. The planet, for all its quiet warning signs, seems healthy, balanced, full of color and motion. And still, above it all, the asteroid moves closer. No sound reaches Earth. No flicker crosses the horizon. Not yet. The jungles remain still. The rivers continue their slow journeys through green valleys. The winds roll gently across the plains, brushing against the skin of creatures that don't yet know this is their final morning. Everything is in place, and time is running out. It was unlike anything the Earth had faced in millions of years. Long before it lit the sky, before it roared through the atmosphere, and before it struck the planet with unthinkable force, the Chicxulub asteroid was just another piece of wandering rock. Cold, silent, ancient. It was born in the outer reaches of the solar system, a carbonaceous chondrite, rich in carbon, minerals, metals, and dust that predated the Earth itself. This kind of asteroid is among the most primitive material in the universe, a frozen time capsule of the early solar system. Some of its contents, tiny grains called calcium aluminum inclusions, are over 4.5 billion years old, older than the planet it would one day destroy. Its surface was rough, jagged, dark, its core solid and dense. It held the building blocks of life, and the power to end it. The Chicxulub asteroid wasn't just massive, it was colossal, estimated to be about 10 to 12 kilometers across, roughly the size of Mount Everest, and weighing hundreds of billions of tons. But it wasn't its size alone that made it deadly, it was the speed. By the time it approached Earth, it was traveling at more than 20 kilometers per second, over 70,000 kilometers per hour. At that velocity, even small objects become devastating. But this wasn't small. This was a mountain moving faster than sound, faster than the eye could follow. The question of how it ended up on this collision course is one that scientists have been chasing for decades. It likely began with a shift, a subtle disturbance in its orbit, possibly triggered by the gravitational tug of Jupiter, the largest planet in our solar system. Jupiter's immense mass can act like a slingshot, pulling nearby objects into new trajectories or flinging them inward from the asteroid belt, the crowded region between Mars and Jupiter where countless fragments of rock circle the Sun. From there, the asteroid may have taken thousands, even millions of years to drift closer to the inner planets. Its path wasn't fast, but it was steady. Every orbit brought it a little nearer to Earth. At some point, its timing and angle lined up with terrifying precision. That's what made Chicxulub different. Most asteroids that enter Earth's atmosphere burn up harmlessly. They're too small, too fragile. They shatter into harmless streaks of light, shooting stars we barely notice. Earth's atmosphere is thick enough to stop most cosmic intruders. But Chicxulub wasn't like the others. It was too big, too fast, and too solid to break apart. Instead of crumbling, it punched through the sky like a cannonball, pushing aside air that had nowhere to go. The pressure ahead of it turned the atmosphere into a wall of fire. The rock itself glowed white hot, not because it was burning from friction, but because the air in front of it was compressed so violently that it superheated. But even in those final seconds, it hadn't slowed much. By the time it reached the skies over what would one day be the Yucatán Peninsula, it was still moving at near incomprehensible speed. The force of impact would release more energy than a billion nuclear bombs, and that energy would be unleashed in less than a single second. But this moment, the end, was just the last page of a much longer journey. The Chicxulub asteroid had traveled millions of kilometers across space, quietly weaving its way through the solar system, passing other planets, other moons, other rocks. It had crossed invisible lines in perfect silence, no flames, no warning, just slow, relentless movement toward one specific point on a blue and green world. It was a traveler with no intent, no malice, no awareness of what it was about to do. It didn't know that it would mark the boundary between the age of reptiles and the rise of mammals. It didn't know that it would crack the planet's surface, fill the sky with fire, and silence creatures that had ruled the Earth for over 150 million years. It was just a rock, but it had all the right or wrong conditions, and now there was nothing left to stop it. It is just after sunrise in what is now the Yucatán Peninsula of Mexico. The land is still, humid, quiet. In the trees, insects buzz lazily through beams of golden light. Shallow coastal waters sparkle just beyond the mangrove forests. Dinosaurs graze at the edge of the jungle. Birds flit between branches. Pterosaurs glide above the shore, wings casting long shadows over the sand. And then, without warning, the sky explodes. There is no buildup, no time to react. 1 second, the world is calm. The next, it is torn apart. From space, the asteroid appears as a glowing blur. Traveling at 20 kilometers per second, more than 72,000 kilometers per hour, it pierces the atmosphere in an instant. The air in front of it compresses violently, heating to thousands of degrees in milliseconds. The shock wave travels ahead of the object, ripping through the atmosphere before the rock even touches the ground. It slams into Earth with such force that the crust beneath it doesn't just crack, it liquefies. The asteroid itself is destroyed instantly, but its energy does not vanish. It transfers into the planet, more than 10 billion Hiroshima bombs, all released at once. The impact zone is pulverized. The Earth's surface is blasted open. A crater more than 180 kilometers wide begins to carve itself into the planet in less than a minute. Bedrock melts into magma. Surrounding rock is vaporized on contact. Shock waves travel outward faster than the speed of sound. There is a flash of light so bright it would have outshone the sun. For a moment, the impact site glows like a miniature star. Forests within hundreds of kilometers ignite instantly, not from flame, but from the sheer heat of the air being compressed and superheated. The shockwave races outward, flattening everything in its path. Trees are torn from the ground, lakes are blown dry. The very air turns into a weapon, a wall of wind and heat moving faster than anything on land can escape. Just beneath the surface, Earth's crust bends and ripples, unable to contain the force. Layers of rock fracture like glass. Liquefied stone is launched into the sky. Some pieces are flung into space, while others arc high above the planet, destined to rain back down like burning meteors. The ocean nearby is thrown upward as if punched by an invisible hand. A massive plume of seawater surges into the sky, evaporating into steam the moment it meets the heat. The shock wave spreads under the seafloor too, sending pulses through tectonic plates, triggering earthquakes across the globe. At ground zero, there is no life left to witness any of it. Every plant, every animal, every living cell within hundreds of kilometers is gone, not buried, not broken, but vaporized. The atmosphere, once thick with moisture and oxygen, now churns with dust, ash, sulfur, and flame. The boundary between sky and ground begins to blur as debris climbs upward, millions of tons of pulverized earth blasted into the air and beyond. Above the impact site, a mushroom cloud of rock and vapor billows into the stratosphere. Superheated gases swirl violently, rising higher than Mount Everest, spreading into a continent-sized canopy of ash. This rising cloud glows red and orange, lit from below by the firestorms still ripping across the landscape. And still, the planet keeps spinning. In places far from the blast, forests, coastlines, deserts, the first tremors are only just arriving. Animals pause mid-step, trees shudder, the ground rumbles softly, then violently. Seconds later, a wall of air hits, flattening everything in its path. Even dinosaurs that lived thousands of kilometers away feel it. They look to the sky, and that's when the rain of fire begins. The instant the asteroid struck, the Earth didn't just react, it detonated. At the point of contact, the energy released was so intense, so sudden, that it didn't just destroy matter, it transformed it. Solid rock, ocean water, soil, and even parts of the asteroid itself were turned into a superheated gas. In less than a second, a massive fireball, over 1,000 miles wide, erupted from the impact site, rising high into the atmosphere and expanding outward in every direction. It moved faster than thought, brighter than lightning, hotter than the surface of the sun. Anything, anything at all, within hundreds of miles, was gone instantly. Not broken, not scorched, gone. Trees, dinosaurs, rocks, rivers, all vaporized in the heat, no trace left behind. The core of the fireball reached temperatures so extreme that sand turned to glass, stone became liquid, and metal evaporated into vapor. The pressure at the center of the blast crushed the air so tightly that it formed a wall, an invisible shock front, racing outward from the center, faster than sound. This shock wave didn't stop at the land's edge. It traveled through the ocean, pushing walls of water away from the crater at impossible speeds. The sea didn't rise, it exploded outward, forming towering surges that had no rhythm, no shape, just raw energy. Beneath the waves, the pulse tore through layers of water like a blade, stunning or killing marine life instantly. On land, the shock wave rolled across the terrain like a moving wall of destruction. Forests miles away were flattened in seconds. Massive dinosaurs were thrown to the ground, bones crushed, lungs collapsed from the pressure alone. The sound alone was enough to kill, a deep, tearing roar louder than anything the planet had ever produced. It moved faster than thunder, shaking the air itself. Some scientists believe the blast was so loud and so forceful that it could have ruptured internal organs in creatures standing thousands of kilometers from the crater. It wasn't just a noise, it was a wave of compressed air, strong enough to split trees, shatter eardrums, and break bones. It crushed everything it touched, including the bodies of animals that never even saw the flash. The Earth's crust, shaken violently, rippled in slow, bending waves, bouncing seismic energy across entire continents. In some places, mountains shifted slightly, in others, dormant fault lines snapped awake. The ground moved like water, bending, breaking, and reforming as the force raced through it. Farther from the epicenter, the heat and pressure came not as a wall, but as a whisper, an eerie, growing hum. The sky darkened, the wind picked up, animals paused, sensing something they couldn't understand. Then the wind became a gale, then a scream, and then a wall of air and flame. Even where the fireball didn't reach directly, its effects did. Glowing chunks of molten rock, some the size of cars, were thrown into the sky by the explosion and began to fall back to Earth. These weren't soft embers, they were flaming boulders, hurtling through the atmosphere, setting fires wherever they landed. One by one, they lit forests, plains, and valleys aflame, starting global wildfires before the fireball itself had even faded. And above it all, the expanding cloud of vaporized rock and metal continued to grow, punching through the upper atmosphere and spilling into the stratosphere. Inside that cloud, tiny particles of glass and ash began to form, materials that would eventually circle the globe and block out the sun. But in this moment, none of that mattered yet. What mattered was the sheer power of the blast, its heat, its shock, its unstoppable force. The animals that lived through the first seconds didn't have time to understand. One moment, they were standing in sunlight. The next, the air caught fire, the ground collapsed, the sky turned white, and then red. As the fireball continued to expand, its light began to dim, partially blocked by the very ash it created. Shadows returned to the land, but they came twisted, long and flickering. The fires cast a strange dancing glow across the smoke-filled air, and the shock wave kept going. It didn't stop with one pulse, like a ripple in a still pond. It moved outward, colliding with mountains, echoing through oceans, bouncing off valley walls, traveling farther than anyone could have imagined. Across the planet, animals lifted their heads. The world was no longer quiet, and soon it would begin to burn. At the heart of the devastation, there was no time. Within just seconds of impact, everything within a 1,000-kilometer radius was either obliterated or consumed. An entire region spanning more than half the width of the continental United States was transformed from a thriving ecosystem into a crater of molten stone, ash, and silence. This was the immediate kill zone, and it left no survivors. Near what is now the Gulf of Mexico, the once lush coastal forests were gone. Not burned, not buried, just gone. Trees didn't fall, they shattered. Giant trunks that had stood for centuries were splintered into dust, stripped of leaves, branches, bark, every layer torn apart by sheer force. The ground itself was erased, replaced by a raw open wound in the Earth's surface. What was once a dense and tangled forest floor now looked like a furnace had passed over it. The heat radiating from the blast zone was so intense that it ignited everything in its path before the shock wave even arrived. Grass turned to ash, stone glowed red, and then melted. Air itself became lethal. In the ocean, the destruction was just as terrifying. The warm, shallow waters that had once supported coral reefs and marine reptiles were turned into a roiling cauldron. Near the point of impact, the ocean literally boiled. The intense heat from the fireball, combined with the shock wave, vaporized millions of gallons of seawater. In an instant, steam surged into the atmosphere in giant plumes, carrying salt, heat, and water droplets into the upper sky. Creatures swimming nearby, turtles, fish, ammonites, mosasaurs, stood no chance. Scalded by the temperature and crushed by the pressure wave, they died in seconds. In deeper areas, the shock rippled through the water with enough force to burst eardrums, rupture internal organs, and collapse entire food chains before they could react. The force of the blast didn't just stay at the surface, it punched down into the crust, liquefying rock and sending fractures deep into the Earth's foundation. The impact melted the surrounding bedrock, forming what scientists later discovered as a unique type of geological glass, evidence that stone had once flowed like lava. Parts of the planet's crust were hurled skyward, thrown not just into the air, but beyond the atmosphere, some escaping Earth's gravity altogether. In the blast zone, shock waves raced through the rock itself, transforming the very structure of the minerals underground. Under extreme pressure and heat, quartz grains common in Earth's crust were warped into something strange. The atomic structure of the crystals twisted into patterns never seen in normal conditions. This twisted material is now called shocked quartz, and it remains one of the clearest fingerprints of an asteroid impact. It doesn't form in volcanoes. It doesn't come from erosion or time. It only appears when stone is hit by something unimaginably fast and unimaginably violent. And it wasn't the only sign left behind. Scattered across the globe, buried in rock layers from the exact same moment in time, scientists have found tiny glass beads called tektites. These are droplets of molten earth and asteroid material ejected into the sky by the force of the explosion, then cooled and hardened as they fell back to the ground. Some landed thousands of kilometers away, others crossed oceans. A few rained down on what is now the other side of the world. They are small, dark, and easy to overlook, but they tell a terrifying story. Each one is a frozen moment, a trace of the exact second when Earth's surface turned to fire. Within the core of the kill zone, no trace of life remained. The plants, the animals, the soil, the rivers, all of it was gone, replaced by a blackened wasteland of molten rock, ash, and silence. And yet this was only the beginning, because beyond the blast zone, outside the 1,000-kilometer circle of instant death, the destruction had only just begun. The firestorm was spreading, the skies were darkening, and soon every living creature on Earth would feel the consequences of what had happened here. 5 minutes have passed. The crater is still glowing. 1,000 kilometers of land are already silent, scorched and lifeless. But now something even more devastating is beginning, something that will touch nearly every corner of the planet. The sky begins to change. What was once blue is now a swirling mix of smoke, steam, and rising ash. The clouds glow red, lit from below by fire and molten earth. From the impact zone, millions of tons of debris have been launched upward, chunks of rock, molten droplets, and fine particles of dust. Some pieces fly just a few miles before falling back. Others arc high into space, only to be pulled down again by Earth's gravity. And now they're coming back, the ejecta still burning hot, begins to rain down on the earth like a storm of falling stars. At first, it looks like nothing more than glowing dust, harmless specks drifting through the atmosphere. But each of those specks is moving fast. Many are still molten, others are razor sharp fragments of glass and rock, heated from re entry as they tear back through the sky. As they fall, they strike treetops, grass, rooftops, even animals, and everything they touch catches fire. The air itself begins to heat, not from flame, but from something invisible. As the debris re enters the atmosphere, it creates a layer of intense infrared radiation, a kind of heat so powerful it doesn't need to touch the ground to kill. This radiation begins to pulse across the surface, spreading in waves faster than any wildfire. Within minutes, the world starts to cook. Forests thousands of kilometers from the impact site suddenly erupt into flames. Dry leaves, damp moss, even wet branches. Everything ignites at once, not from sparks, but from the overwhelming heat pouring down from the sky. Entire ecosystems light up in an instant. On the ground, herds of dinosaurs lift their heads, eyes wide, confused by the strange glow above. The temperature is rising rapidly, not like a summer day, not even like a desert sun. It's more like standing in an oven that's just been turned on high. The heat doesn't come from below, it comes from all directions. Small creatures drop where they stand, birds fall mid flight, amphibians try to bury themselves in mud, only to find it baking around them. Larger animals run, confused, not knowing what they're running from. There's nowhere to go. The wind picks up, carrying embers across dry plains. Firestorms begin to form, violent towering infernos that spin like tornadoes, pulled upward by their own heat. They roar across the land, devouring trees, plants, nests, everything in their path. The sky darkens further as smoke fills the air, blocking out the last of the sun. Every continent begins to feel it. Even places untouched by the initial blast are now choking on heat. In what will one day be North America, Asia, Africa, and Europe, the fires begin to merge, growing so large they create their own weather, storms of fire and lightning, swirling with ash and choking gas. Animals retreat into caves, under rocks, into water, anywhere that might offer protection. Some will survive, but many will not. The air is becoming toxic, not just from heat, but from the chemicals released by burning forests and vaporized minerals. Oxygen levels drop, breathing becomes harder, movement becomes slower, eyes sting, lungs tighten, and still the fire keeps falling. Tiny droplets of glass tektites sizzle as they land in shallow ponds and rivers. Water evaporates with a hiss, the surface of lakes begins to steam, insects vanish, flowers wilt, seeds that had waited patiently for rain are now being baked into the dirt. The Earth's surface is becoming unrecognizable. All of this within just 5 minutes. It's not the asteroid alone that ends the dinosaurs' world, it's what comes after: the falling fire, the invisible heat, the global chain reaction sparked by a single point of contact. Above, the last of the glowing debris begins to fall, like sparks drifting from a dying flame. But the damage is already done, and as the fires continue to burn, the planet begins to shift again, beneath the surface and across the seas. Beneath the fire, beneath the smoke, beneath the rain of glowing debris, the Earth is still shaking. The asteroid's impact didn't just tear through the sky and scorch the surface, it struck with such force that the very bones of the planet were rattled. In that first split second, seismic energy was released on a scale no fault line had ever known. A magnitude 11.0 earthquake, something beyond any recorded in human history, rippled outward in every direction. The crust didn't just shift, it snapped. Rings of seismic waves spread from the impact zone like shock waves on a drum. They raced through the ground, traveling through solid rock, sliding under oceans, crossing mountains, and slamming into continents thousands of kilometers away. As the waves moved, they cracked faults, uplifted seabeds, and buckled land masses with raw, unstoppable energy. The tremors reached what would become North America, then South America, then Europe and Africa, rattling the plates under Asia, Australia, and even Antarctica. In some places, the ground simply shook. In others, it split open, cracks tearing through ancient forests, rivers rerouted in an instant, landslides thundered down slopes, cliffs broke free from their walls and collapsed into the sea. But the earthquakes were only part of what came next. Out at sea, something even more terrifying was building. When the asteroid struck, it not only blasted a hole in the land, it also punched into part of the ocean. Trillions of gallons of water were thrown upward, vaporized into steam, or shoved outward in massive swells. But that was only the beginning. As the crater deepened and the seafloor ruptured, the displaced water collapsed back inward. Enormous tsunamis began to ripple outward, born not from weather or wind, but from the sheer displacement of Earth's crust. These weren't waves, they were walls. Some were as high as 300 feet, taller than most skyscrapers, and they moved faster than any animal could run. They rushed toward the coastlines at jetliner speeds, growing taller as they entered shallower water. When they reached land, they slammed into shorelines with explosive power, crashing through forests, tearing up soil, flooding lowlands, and dragging everything in their path back into the ocean. On islands and coastal plains, entire ecosystems were swept away. Dinosaurs grazing near beaches were carried off their feet. Nesting colonies of pterosaurs were drowned in seconds. The few animals that tried to flee were overtaken by water so powerful it pulled trees from the ground like weeds. The wave didn't stop when it hit land, it pushed inland for miles, reaching hills, valleys, even some mountainsides, before finally losing momentum. And when it did stop, it didn't retreat peacefully, it sucked everything back with it. Dead animals, trees, boulders, mud. It all flowed backward like a slow motion avalanche in reverse, dragging debris into the sea. The coastlines were no longer recognizable, shorelines were redrawn, rivers flooded backward, new lakes formed where valleys had once stood. Even far from the ocean, strange things were happening. The inland seas that covered much of the central continent, huge shallow bodies of water that divided what is now North America, began to move violently. Seismic waves shook their muddy bottoms, triggering underwater landslides. The water sloshed back and forth like it was trapped in a massive bowl, emptying out of one end and crashing into the other with terrifying force. Entire sandbars disappeared, coastlines eroded overnight. Shallow marine life, corals, shellfish, small marine reptiles were crushed under the weight of collapsing sediment and drowning waves. In the days to come, some areas would flood permanently, others would drain and never refill. The map of the Earth was already starting to change, not over centuries, but in a matter of hours, and beneath the surface, aftershocks continued. The Earth wasn't done shaking. The crust, now wounded and stressed, continued to crack and tremble. Volcanic zones far from the impact site began to respond. Pressure that had been building for thousands of years suddenly had a release point. Deep in the ground, magma started to stir. But above all this, above the fractured land, the boiling seas, the drowned forests, and firelit skies, something else was happening. The air was starting to change. The planet trembled. And far from the crater, something deep beneath the surface began to stir. The shock of the impact had not stopped with fire and waves. It had reached down into the mantle, sending invisible vibrations across the globe, rippling through the liquid rock beneath the crust, disturbing pressure points that had been building for millions of years. In what is now western India, a sleeping giant began to wake. This region, already geologically unstable, held one of the largest volcanic systems the Earth had ever known, the Deccan Traps, a vast plateau of layered basalt rock built from eruption after eruption, each one spilling rivers of lava across the landscape. For hundreds of thousands of years, these eruptions had come and gone in pulses, slow and sporadic, shaping the terrain without drawing much attention. But now the balance had tipped. The Chicxulub impact, with all its violence, may have been the trigger. The pressure wave from the collision jolted the planet's crust like a hammer striking a bell. Deep beneath the Indian subcontinent, chambers of magma that had been rising steadily suddenly burst free. Fissures cracked open, stretching for hundreds of kilometers, and through them lava surged to the surface. The Earth didn't erupt in a single blast, it bled endlessly. Thick, dark lava poured from the cracks, flowing like liquid rock across valleys, forests, and floodplains. Some flows stretched for hundreds of miles, burying everything beneath them. Trees vanished, rivers were swallowed, entire ecosystems disappeared under waves of molten stone. But the lava wasn't the most dangerous part. What rose into the sky above the lava was far worse. With each new pulse of eruption, the Deccan Traps released enormous clouds of gas, billions of tons of sulfur dioxide, carbon dioxide, ash, and aerosols shot violently into the atmosphere. The gases didn't just linger near the vents, they rose, caught by thermal currents, and drifted high into the stratosphere, where they began to spread across the globe. The sulfur dioxide quickly combined with moisture in the atmosphere to form sulfuric acid droplets, tiny reflective particles that blocked sunlight. A thick gray veil began to spread around the planet, dimming the skies even farther. What the asteroid hadn't already darkened with soot and debris, the volcanoes now blotted out with chemical haze. Below, sunlight weakened, photosynthesis slowed even more, and with it, the oxygen supply. Temperatures, already beginning to drop from the earlier chaos, started falling faster as solar radiation was reflected back into space. The planet was cooling, and fast. But at the same time, carbon dioxide, a greenhouse gas, was pouring into the atmosphere from the same eruptions. And that created a long, slow conflict in the climate system. Short-term cooling from sulfur and ash, battling long-term warming from trapped heat. The Earth's climate, once stable and lush, was now spiraling into a volatile and unpredictable state. Weather patterns shifted, rain became acid, winds carried sulfur across oceans. The air grew thicker, heavier, and harder to breathe. And still, the Deccan Traps did not stop. The eruptions would continue for thousands of years, layer upon layer of basalt building up, forming a staircase of rock that would one day cover more than 500,000 square kilometers. But in these early days, just after the impact, it was the sudden release of gas that mattered most. Animals trying to escape the fires and flooding now faced toxic skies and suffocating air. Some collapsed from exhaustion. Others wandered through landscapes that no longer offered shelter or food. Lakes turned acidic. Rivers carried ash and poison. The forests that hadn't burned were slowly dying in the dark. And it wasn't just India. Volcanic chains around the world, less famous than the Deccan Traps, but still powerful, began to react in smaller ways. Subduction zones trembled, deep-sea ridges hissed and fumed. Even long dormant volcanoes stirred slightly, uncertain but active. The planet was no longer just recovering from a collision, it was changing from within. As the lava flowed and the gases rose, a new phase of extinction began, not with heat, but with chemistry. And above it all, the sky was no longer blue. It was gray, and growing darker still. The fires still burned, But now the world was growing darker. High above the scorched earth, above the shattered forests and flooded plains, the sky was changing. What began as a swirling veil of smoke and ash was now becoming something else entirely, a blanket of darkness that stretched from one horizon to the other. Millions of tons of debris had been launched into the sky during the impact: fine dust, soot, vaporized rock, sulfur rich gas, and tiny droplets of molten glass. And now, all of it was spreading across the planet, circling the globe high in the stratosphere, where winds moved faster and the weather below could not wash it away. The sky, once blue and full of light, turned to a murky gray, then to brown, and then finally to black. It didn't happen in an instant. At first, the sunlight dimmed like an early dusk. Shadows lengthened too soon. Then, day by day, the world grew quieter, not from silence, but from the absence of light. Morning came without warmth. Noon arrived without brightness. Even places far from the crater, places untouched by the fires or the tsunamis, were now falling under the same strange twilight. And then the sun disappeared completely, for days, then weeks. Beneath the heavy clouds of ash and aerosols, the earth began to cool, not gently, not slowly, but fast. Without the sun's rays reaching the ground, temperatures plummeted, warm forests turned cold and wet. Coastal air lost its warmth. Even the tropical regions, once thick with humidity and heat, began to feel the bite of cold mornings and frozen nights. Frost formed on the leaves of dying plants, ponds began to crust over, snow fell in places that had never seen it before. Animals, confused by the darkness and chill, wandered without direction. Some tried to migrate, others curled into hollows and waited. But the food was vanishing fast, and not just because of the cold. The true collapse had begun. Without sunlight, photosynthesis stopped. Plants that had survived the fires and the floods now began to die from lack of light. Leaves withered, buds never opened, crops and flowering plants failed to grow. Entire forests dimmed from green to brown as the energy that powered Earth's food web shut down. It took only a few days for the first layers of the food chain to break. Algae in lakes and oceans, cut off from the sun, stopped producing oxygen and nourishment. Phytoplankton, the microscopic plants of the sea, began to die in massive numbers, causing the collapse of everything that fed on them. Tiny fish starved. Coral reefs, already battered by heat and acid, began to bleach and crumble. Marine life grew sluggish. Deep sea creatures that relied on surface food to rain down in particles found themselves suspended in growing emptiness. On land, the pattern followed close behind. Herbivores, plant-eating dinosaurs, insects, mammals, and reptiles struggled to find food. Fields once covered in edible vegetation now stood barren. Young animals grew weak. Adults fought over scraps. Migration routes became graveyards. And the predators? They held on only slightly longer. With herbivores dying or gone, carnivores turned desperate. Some turned on each other. Others starved in silence. Too large to adapt quickly, too specialized to survive in a world suddenly drained of prey. The cold deepened. The darkness thickened. The earth had entered a kind of nuclear winter, though no war had caused it. This was nature's war, triggered by rock, fire, and sky. And still, the skies did not clear. The sulfuric aerosols, launched high by both the impact and the volcanic eruptions that followed, remained suspended for months. They reflected sunlight back into space, cooling the planet further, amplifying the freeze. The carbon dioxide released by the Deccan Traps would eventually tip the planet back toward heat, but that warming was still far off. For now, the chill ruled, and the silence grew. Birdsong vanished, insects stopped buzzing, dinosaurs no longer thundered across the plains. The earth was still alive, but quieter, slower, darker than it had been in millions of years. And this was only the beginning of what the darkness would take. 12 hours have passed since the impact, and the world is no longer recognizable. The sun, still hidden behind a churning wall of ash and gas, offers no warmth. Daylight never truly arrives. The sky hangs low, thick and bruised, with no color, no shape, no movement, a dead ceiling above a wounded planet. The temperature has dropped fast, too fast. Across the globe, in just half a day, the average global temperature has plunged by more than 30 degrees Celsius, over 86 degrees Fahrenheit. Places that were once warm and humid are now gripped by sudden cold. The transition is brutal. Trees, adapted to stable climates, begin to shut down. Leaves freeze overnight. Roots stop drawing water. Growth stops entirely. The soil, still steaming in places from fire and lava, begins to harden under the unexpected chill. Frost creeps over plant stems like a slow death. Moisture crystallizes. Photosynthesis had already halted in the darkness. Now the cold makes it impossible to start again. In forests that haven't burned, the trees are still dying. In open fields, grasses that once waved in the breeze lie flat and blackened, either burned by heat or killed by frost. Insects that once clung to stalks or hovered in clouds above flowers are falling motionless to the ground. Their bodies pile up in quiet, frozen layers. The animals feel it next. With the plant life gone, the food chain collapses. Herbivores that managed to survive the fires now face a new threat: starvation. Massive creatures that once roamed open plains in great herds are now weak and shivering. Their breath curls in the cold air. Their stomachs rumble, empty. Their legs grow unsteady beneath them. Some lie down exhausted and don't get back up. The small ones, creatures that hid from the heat, underground or beneath rocks, emerge into a world that offers them nothing. The soil is too cold, the seeds are gone, there are no fruits, no shoots, no soft leaves to nibble. For many, the search for food becomes a slow, wandering spiral. They walk until they can't. Carnivores, too, are running out of time. The meat they relied on is vanishing. A few scavenge from bodies left behind in the fires or floods, but those carcasses rot quickly or freeze solid in the cold. Predators turn on each other, not in coordinated battles, but in scattered, desperate attempts to survive just a little longer. And then there are the scavengers, the creatures that usually wait for death and feast afterward. Even they are dying now. The cold reaches everywhere. The darkness doesn't lift. The bodies stop coming because there is nothing left to feed on. Insects that normally break down the dead are frozen or suffocated. Bacteria, which rely on warmth and moisture, go dormant or die off in massive numbers. The usual cycle, life to death to decay, has stopped. It's not just silence, it's stagnation. Even the oceans are changing. Surface waters cool rapidly without the sun's energy. Phytoplankton, the base of the marine food chain, are dying by the millions. Without them, everything in the sea begins to starve. Fish populations crash. Coral reefs, already damaged by the earlier waves and fires, begin to crumble in the dark. The creatures that had once filled every niche, flying, crawling, swimming, running, are now fewer, colder, and hungrier. The survivors move slowly, conserving what little energy they have left. Many no longer move at all, but not all is still. Beneath the soil, where the temperature changes more slowly, tiny mammals begin to stir. These creatures had dug deep to escape the fire and heat. Now they remain hidden to escape the cold and hunger. They feed on whatever remains: seeds, roots, even the bodies of the dead. Their small size means they need less to survive. Their warm blood keeps them going just a little longer. They are not thriving, but they are hanging on. Above ground, however, the world is fading fast. Each hour brings colder air, thinner food, and a sky that seems even heavier than before. The earth, once loud with movement and song, is now a place of flickering fires and scattered bodies, and the darkness hasn't even lasted a full day yet. Below the darkened skies, beneath the cooling air and falling ash, another disaster is unfolding, this one in silence and underwater. The oceans, which once shimmered under the sun, now lie dark and still. Their surface is cooler than before, covered in floating ash and debris. Waves roll gently, not from wind, but from the aftershocks that continue to ripple through the seafloor. The air above them carries strange new chemicals, and now those chemicals are starting to sink in. Carbon dioxide released from the Deccan Traps and the burning of Earth's forests is being drawn down into the water. So is sulfur dioxide, launched into the upper atmosphere during the impact, and from countless volcanic vents that are now wide open. These gases don't just disappear when they reach the ocean, they dissolve, forming weak acids that spread through the water column, slowly at first, then with growing speed. The oceans begin to change, not all at once, but cell by cell, layer by layer. The surface waters, once teeming with invisible life, are the first to feel it. The acidity rises, the chemical balance tips, and for many organisms, that's all it takes. The first to die are the smallest. Phytoplankton, microscopic plants that float near the surface, are among the first casualties. These tiny organisms form the foundation of nearly every marine food chain. They feed on sunlight, using photosynthesis to grow, reproduce, and release oxygen. But now, there is no sunlight to feed them, and as the water grows more acidic, their delicate outer layers made of calcium or silica begin to dissolve. Without phytoplankton, everything begins to unravel. Zooplankton, the small drifting animals that feed on phytoplankton, begin to starve. With their food source disappearing, their numbers fall sharply. This leaves small fish and filter feeding species with nothing to eat, and from there, the collapse moves upward. Coral reefs, already stressed from shock waves and debris, now face chemical assault. Corals rely on stable pH levels to maintain their calcium carbonate skeletons, but as the acidity increases, they can no longer build or repair their structures. Instead, their skeletons begin to dissolve from within. Color fades, polyps die. Entire reef systems, once bursting with color and movement, begin to fall apart. Reefs were more than just structures. They were homes, nurseries, shelters for thousands of species. With them gone, the ocean becomes open and bare. The mid-sized fish, the predators, the schools that once darted through reef channels, now swim through silence. They search for food that no longer exists. Their bodies shrink, their movements slow, they begin to disappear, and in the open ocean, the giants suffer too. Marine reptiles like mosasaurs and plesiosaurs, which once ruled the seas, now find themselves adrift in a world with nothing to hunt. Their prey, fish, squid, smaller reptiles are dying off or have already vanished. They roam wide, covering more distance each day, but it leads nowhere. The sea is emptying. Even sharks, adaptable and efficient, are not spared. Some can survive longer than others, feeding on scraps or turning to scavenging, but the food web they depended on is broken at every level. Their movements grow slower, their energy fades. The young stop growing, the old begin to die off, one by one. The water itself is changing too. It grows more acidic with every passing day. It stings the gills of fish, it changes the smell of currents, it alters the way chemical signals travel, making it harder for creatures to communicate, to hunt, or to detect danger. Species that had existed for millions of years, unchanged, perfected by time, can no longer recognize the ocean they live in. The deeper waters don't offer much refuge either. Though cooler and more stable, They depend on organic matter drifting down from above. But now, that rain has stopped. The food that once sank from the surface to feed the deep is gone. Darkness settles there too, colder, quieter, emptier than before. The oceans are not just places of water, they are living systems, networks, chains of survival stretching across species, across time, and now those chains are breaking. Above, the land is cold, the skies are dark, but beneath the waves, the collapse is just as complete, slower, quieter, but every bit as final. The skies had dimmed, the oceans had begun to rot, and across the land, hunger was tightening its grip. The fires, the cold, and the darkness had already weakened the world. But now, as the days passed with no sunlight and no growth, a different kind of silence began to take over. The silence of bodies growing still from starvation. The first to fall were the giants, massive plant eating dinosaurs, hadrosaurs, ankylosaurs, triceratops, and long necked titanosaurs had once dominated the forests and plains. Their size had always been their strength. With towering necks, heavy armor, and herds for protection, they could intimidate predators and cover vast distances in search of food. But now there was no food left to find. The forests were either burned, buried in ash, or dead from cold. The ferns had browned and collapsed. The flowering plants had withered. Even the mosses and soft ground cover had frozen under the rapid temperature drop. Nothing new was growing. These herbivores, once so powerful, were now helpless. Their massive stomachs, designed to slowly digest mountains of plant matter, were empty. Their strength faded quickly. Some wandered in circles, chewing bark and dry branches in desperation. Others fell to their knees, too weak to rise again. Herds began to thin. Tracks stopped leading anywhere, and one by one, the largest animals on land disappeared. Without them, the balance shifted again. For a time, the apex predators still roamed. Tyrannosaurs, abelisaurs, and other meat eaters scavenged what they could, feeding on the dead and the dying. At first, there was plenty. The forests were littered with corpses. The plains were full of half-eaten remains. The ocean had thrown bodies onto the beaches. But it wasn't a stable feast. It was a countdown. As the herbivores vanished, so did the predators' supply of fresh kills. Hunting became pointless. There was nothing left to chase. And though many could scavenge, even that came with limits. The largest predators needed a steady source of meat, more than the dying world could offer. Some turned on each other. In rare moments of desperation, fossils tell us that cannibalism may have occurred. Bite marks on bones, claw wounds on the backs of the weak, but even that couldn't last. The hunger was too deep, the cold too sharp, and like the herbivores before them, the great hunters began to collapse. Their footsteps grew lighter, their bones grew sharper under their skin, they dragged their tails, their heads hung low. With no food and no warmth, even the strongest carnivores fell, scattered across the world like shadows frozen in place. In the fossil record, their exit is sudden. One layer shows the normal world, tracks in the mud, nests with eggs, bones arranged where they fell. Then, just above that, the layer of impact debris, a thin line of ash and iridium-rich dust formed from the vaporized asteroid and Earth itself. And above that, nothing. The bones are gone. The tracks vanish. The record of life ends in an abrupt line. One moment the dinosaurs are everywhere, and the next they're gone. Paleontologists call this the Cretaceous Paleogene boundary. It's marked in stone, in cliffs, and in canyon walls across the globe. A dark band, only centimeters thick, but it tells the story of a world that died in weeks. It wasn't just dinosaurs, reptiles, flying pterosaurs, sea creatures, anything large and specialized disappeared quickly. Their size, which once gave them power, now made them slow to adapt. They needed more food, more territory, more stability, and none of those things existed anymore. Even the nests went cold, eggs left unhatched, young left unfed, whole generations ended before they began. Yet while the giants fell, the world did not go completely quiet. Beneath the brush, in burrows, in the shadows, something else was still moving. The survivors were not large, they were not fast, but they were small enough to eat almost anything and tough enough to keep going. And as the great ones vanished above them, the age of giants was giving way to something new, not with a roar, but with a whisper. As the towering beasts collapsed and the oceans grew silent, the very air itself turned against the survivors. Breathing, something once automatic, effortless, now came with a price. The skies, once bright and open, were choked with a thick, unrelenting haze. After the fires swept across continents and the volcanoes awakened in fury, smoke and ash began to spread like a dark second skin across the planet. It wasn't just a gray smog that hovered overhead, it was physical, tiny, jagged particles suspended in the air, drifting like invisible glass dust through every breath, every gust of wind, every gasp for survival. Even in places far from the crater, the air was no longer safe. Ash plumes had traveled halfway around the globe in a matter of hours. The fine debris, light enough to float for weeks but sharp enough to damage tissue, found its way into every valley, every burrow, every crevice where life still clung on. The smallest creatures were the first to notice the change. Insects fluttered lower to the ground, their wings growing slower, more erratic. Amphibians emerged from mudbanks only to retreat again, overwhelmed by the dryness and grit. Tiny mammals coughed in their burrows, their soft fur catching dust like sponges. But the ash didn't discriminate. Large or small, lungs filled with soot, breathing became an act of effort, airways inflamed, eyes burned, noses bled. Even the most robust survivors began to wheeze and stagger, moving more slowly, pausing more often, their chests heaving harder each time. The oxygen-rich world that had once supported giants was fading. With the sun blotted out and photosynthesis halted, oxygen levels in the atmosphere began to fall. Not dramatically all at once, but enough that creatures used to a higher supply struggled. The drop didn't just choke animals, it stole their stamina. Simple acts like walking or foraging turned into draining tasks. Some collapsed in mid-step, others curled into themselves, too exhausted to rise again. Birds, which relied heavily on a fast and efficient breathing system, began dropping from the sky. Some species had survived the initial shock, but now their wings couldn't carry them far. Flight became rare, nests grew cold, their calls faded into silence. On land, the ground was littered with the still bodies of animals that hadn't been injured, burned, or frozen, but had simply run out of breath. And as the animals struggled for each breath, a quieter transformation began beneath their feet. In the damp, dark places where life had fallen still, another world was waking up, a world of decomposers. Fungi, long hidden beneath the forest floor or clinging quietly to trees, now found an open field. There was no competition, no sun to hold them back, and everywhere there was decay, rotting leaves, half-buried corpses, wet ash soaked with organic matter. Spores drifted through the air like pollen in spring, except now the air was cooler, heavier, and more welcoming to their spread. Entire landscapes began to change color, coated in mats of white, gray, and sickly green mycelium. Where predators once prowled, mushrooms now bloomed. Where herds once grazed, thin stalks of fungal life reached upward. And with the fungi came the microbes, tiny ancient creatures that thrived in disaster. Bacteria surged in the soil, feeding on carbon, sulfur, and remnants of protein left behind. Some glowed faintly in the darkness, others excreted acidic waste that carved new textures into fallen bones. Even in the oceans, where fish and marine reptiles struggled to breathe through clogged gills and acidic waters, microscopic life was rising. Algal blooms spread across the surface. Bacterial colonies turned coastlines into chemical soup. The water, once crystal blue, now shimmered in shades of red, green, and brown. It wasn't life as the world had known it. It wasn't life with legs or teeth or feathers, but it was life, life feeding on death, breaking it down, repurposing it, spreading across the wounded planet like a slow, creeping memory. And still, above it all, the air remained thick. Even creatures that had survived the first hours, the first fires, the first freeze, now faced a new enemy, invisible, relentless, and everywhere. Each breath was now a burden, and with every passing hour, fewer and fewer creatures had the strength left to keep breathing. Amid the ash-choked skies, the burning forests, and the howling silence left by the fallen giants, something else stirred, something smaller, quieter, and far more adaptable. While the towering dinosaurs lay still, overcome by fire, starvation, or suffocating air, life hadn't vanished completely. Hidden beneath the surface, in the cracks and shadows, were the early survivors, species so small and unassuming they had passed unnoticed during the age of giants. Now, they were all that remained. In the soft, damp soil of ancient riverbanks, burrowers stirred. These creatures, tiny mammals no bigger than a rat, had not seen the fireball nor felt the blast directly. They had tucked themselves into the earth, insulated from the searing heat and deafening shock waves. Their burrows, shallow and crude by modern standards, became accidental bunkers, protecting them not by design, but by habit. These mammals were nocturnal, used to sleeping underground during the day, safe from predators and temperature extremes. Above ground, everything had turned hostile, but underground, pockets of breathable air lingered longer. The soil absorbed some of the heat, and while the earth trembled with aftershocks, the tunnels held just long enough to keep their inhabitants alive. Some of these early mammals had specialized cheek pouches for storing seeds. Others had sharp claws for digging through roots and mud. They weren't strong or fast or even particularly clever by modern standards, but they were survivors. They could live off scraps. They could huddle in groups to conserve warmth. And more importantly, they didn't need much. A few insects, a handful of roots, drops of condensation on the tunnel walls, and they weren't alone. In deeper waters, far from the coasts, aquatic life clung on, not the giant reptiles that once ruled the seas. They were vanishing quickly, starved of oxygen and food. But the smaller, slower creatures, bottom dwellers, burrowers in mud, crustaceans in the sediment, they endured. Their world had turned murky, darker, more acidic, but they had adapted to low light conditions long before. Some lived off detritus, organic particles falling from above, like toxic snow. Others filtered water for microscopic nutrients. Lakes and underground aquifers, enclosed systems less connected to the atmosphere, offered temporary shelter. There, amphibians like ancient salamander like creatures hid among roots and rocks. The water cooled more slowly than the air, and where fire had scorched the land, the mud at the bottom of a pool could still offer refuge. Insect life fared better than most. In a world suddenly blanketed in death and decay, the insects thrived, not in spite of the destruction, but because of it. Carrion beetles, scavenger ants, and tiny flies erupted in number. They swarmed the bodies of the fallen, laid eggs, fed on flesh, to compose the dead at a scale and speed never before seen. Even some species of cockroach, already ancient by this time, scurried through the ruins, crawling beneath bark, under rocks, into whatever cracks still held warmth. Their exoskeletons shielded them from radiation. Their eggs were resilient. Their diets were flexible. They could eat wood, fungus, waste, whatever the apocalypse left behind. Elsewhere, tiny reptiles, barely larger than modern lizards, hugged the stone surfaces of still warm rocks. They had no fire resistance, no special tools, but they had two key traits: cold blooded metabolisms and minimal food requirements. They moved slowly, hid often, and waited. Those that avoided being crushed or cooked were now alone, watching a quiet world with sharp eyes. Some birds, too, if they could be called that yet, managed to hold on. Feathered, nimble creatures that had evolved from certain dinosaur lines had taken to the trees and air in the final days before the blast. The ones that had nested in sheltered canopies or found cracks in cliffs to hide in may have been spared the direct heat. Those that fed on seeds or insects had a better chance than those that relied on fruit or fish. But perhaps the most unexpected survivors weren't animals at all. Spores, bacteria, microscopic life. These entities didn't run, they didn't hide, they simply endured, adapting their chemistry, waiting for conditions to shift. Some bacteria entered dormant states, others began feeding on sulfur and carbon, turning toxins into energy. Life in its simplest form never stopped. The first 24 hours had taken nearly everything. The air had turned lethal, the oceans had boiled, the sun had vanished. But in the smallest corners of the planet, beneath rocks, within soil, underwater, resistance flickered. These were not the rulers of the old world, but in time they would become the architects of the new one. The sun still hadn't returned. Days blurred into a dim, ashen twilight. The thick curtain of dust and soot that had swallowed the sky continued to smother the light. Not in darkness exactly, but in something stranger, a colorless, hushed gray, like the world had stopped breathing. Where lush forests once stood, only blackened stumps remained. Great canopies that once teemed with life had collapsed into charcoal skeletons, twisted and snapped like matchsticks. The undergrowth, too, shrubs, vines, mosses, was gone, burned, scattered, buried in drifting piles of powdery ash that coated everything like snow, except this snow was warm, heavy, and suffocating. The oceans had changed too, not violently, like during the tsunamis, but eerily still, flat and dark. The waves no longer crashed with the same rhythm. The tides moved slower. Once transparent waters had become soupy and stained, filled with debris, acid, and microscopic death. Coral reefs that once bloomed in kaleidoscopic colors had turned ghostly white, then brittle, then gone. Coastal shores had receded into silence, the boundary between land and sea blurred by layers of silt and dead things. The wind was louder now. With the forests flattened, there was nothing to break its path. It screamed down from the hills, whipped across plains, stirred the ash into swirling devils of dust. It howled through the empty canyons, carrying no scent of life, no pollen, no rain, no musk of animals, just dry minerals and decay. Everywhere, the silence was absolute. No birds took flight, no insects buzzed, no frogs croaked, no predators growled. The sounds that had defined life for millions of years, squawks, howls, chirps, roars, rustles, were gone. The only sound now was the soft hiss of ash settling. It fell constantly, like a whisper from the sky, landing on rocks, on skeletons, on the cracked remains of what once was. It coated every surface in a dull gray film, erasing colors, details, edges, a great equalizer. Everything, no matter how mighty it had been, now lay beneath the same pale dust. In the lowlands, riverbeds had dried into mud-cracked wounds. Their fish were long gone, Their waters evaporated or turned acidic. Amphibians that once sang in the evenings now lay buried in sludge, their forms barely distinguishable. In the highlands, glaciers and snowcaps that once fed those rivers had begun to retreat, not from warmth, but from atmospheric chaos. Even the mountains were changing, slowly. Bones lay everywhere, not picked clean, not scattered, but undisturbed, as if the world had simply paused. Giant rib cages protruded from dunes. Fossilized footprints ended in mid-step. Some bodies were half buried in mudslides, others fossilized in lakes where the water had turned to brine. The outlines of life were frozen in place, as if time itself had shattered. Even plants that had once survived harsh winters or dry summers now failed to sprout. With no sunlight for weeks and ash burying seeds too deep for germination, photosynthesis had gone silent. Leaves crumbled before they ever grew. Roots reached down and found only lifeless soil. The earth, once green and trembling with growth, had gone still. And beneath the surface, though a few species clung to life, even their worlds were changing. Burrows collapsed from constant tremors. Underground lakes became toxic. The microorganisms in the soil shifted, adapting to feed on rot, not roots. Nature's rhythm was broken. Its clock had stopped ticking. There were no seasons anymore, no migrations, no cycles of bloom and harvest, only stillness. Across entire continents, there were places where nothing moved for miles. No wind, no beasts, just open plains coated in pale dust under a ceiling of unmoving gray. At night, there were no stars. The clouds were too thick. At daybreak, the sunrise barely colored the sky, just a faint smudge of light on the horizon, quickly swallowed again. And yet this quiet wasn't peaceful, it was ominous, as if the world held its breath. Every now and then, a gust of wind would topple a scorched tree or scatter a pile of bones. Sometimes, distant tremors could still be felt, aftershocks of the impact or the restless shifting of Earth's crust. The ground itself wasn't done moving, and somewhere, deep beneath the layers of destruction, molten rock still flowed. But above all, there was waiting, an eerie anticipation, as if Earth wasn't finished unraveling, but had simply paused to see what might crawl out from the wreckage next. Because even in silence, the planet was still alive. Not in the way it had been, but in a new, more uncertain way. The rules had changed, the stage had cleared, and the future, though invisible, was beginning to stir beneath the ash. The world didn't end with a bang. It ended with a silence that lingered. As the ash continued to fall like a slow gray rain, weeks passed without a proper sunrise. The skies remained dim, as though dusk had been stretched across the planet and frozen in time. What little light made it through was weak and cold, unable to warm the ground or stir the trees. The air itself felt heavier now, thicker with particles, thinner with oxygen, and colder than most life could bear. Across what was left of Earth's surface, temperatures had dropped sharply, with sunlight blocked by a thick shroud of soot and sulfur aerosols. Daytime no longer brought relief. Nights became brutally cold. Frost settled even in regions that had never seen snow. Ponds turned to ice. Winds bit through whatever cover remained. It was a deep freeze, not one of snowstorms or ice sheets, but of stillness, dryness, and bitter air. And with the cold came hunger. Food, once abundant, had become a memory. The towering trees that provided fruit, shade, and shelter were now blackened poles. The low-lying plants had shriveled into the dirt. Grasses had turned brittle, then vanished under the weight of falling dust. There were no fresh shoots, no blossoming flowers, no seeds to gather. Even the decomposing remains of the fallen beasts began to vanish, picked clean by early scavengers and turned to rot too toxic for others to consume. Animals that had once dominated their ecosystems now wandered aimlessly. Those that hadn't died in the fires or tsunamis or choked on ash were starving. The great herbivores, once lumbering across wide plains, stood gaunt and hollow eyed, mouths filled with lifeless twigs that offered no nutrition. Their bellies, evolved for fermenting lush vegetation, were now empty caverns. Their legs, once strong enough to carry them for miles, trembled under the weight of nothing at all. Predators fared no better. Without prey, there was nothing to hunt. The once mighty jaws of tyrannosaurs, giganotosaurs, and other apex beasts were now useless weapons, their sharp teeth wasting away in skulls too weak to lift. Some turned to scavenging, others to cannibalism, but even those desperate adaptations offered only a few extra days. The starvation was relentless. It didn't care about strength, size, or dominance. It crept into bones, slowed hearts, and silenced roars. And all the while, the sky never cleared. Ash clogged the airways of anything that tried to breathe too deeply. Eyes became inflamed, throats scratched with every inhale. Movement became sluggish. Survival was no longer about instinct. It was about endurance, about finding the smallest, least obvious corner of the world and staying still, waiting, conserving every shred of energy. Only the tiniest creatures seemed to have a chance. Tiny fur-covered mammals with low food needs and warm burrows, insects that could live off decaying matter or lay dormant until conditions improved, amphibians tucked in underground hollows near spring-fed pools, some turtles and lizards that could go weeks without food or light. They didn't thrive, but they endured. In shallow soil, worms wriggled through layers of ash, searching for scraps of organic matter. Beetles gnawed at bark or bones. Fungi began to spread in the dark, feeding off the dead and breaking down the fallen. Life had shifted underground, not metaphorically, but literally. The surface had become a graveyard, but below it, something still moved. Each day that followed brought less noise and more stillness. Some valleys became entirely silent, not a footstep or breath for miles. Others echoed with the final cries of dying creatures or the soft rumble of a collapsing tree. But there were no songs, no chirps, no calls. The world had gone mute. Rivers that had once surged with melted ice and rainfall were now trickles through muddy beds. Lakes shrank, their banks exposing dry, cracked mud where fish had once swum. Even the ocean, vast and powerful, had stilled. The surface swayed gently, but with less force, fewer waves. Like it too had run out of energy. The creatures that had once ruled, those with fangs, claws, horns, or armored plates, were no longer here to shape the land. Their absence left behind echoes, empty nests, footprints that filled with ash, eggs that would never hatch, and for every great beast that fell, a dozen smaller creatures quietly scurried into hiding, not knowing if they'd ever emerge. But through it all, Earth itself kept turning, slowly, patiently, waiting for whatever would come next. The silence deepened. What had started as a single impact, just one object from deep space, had unraveled millions of years of life in mere days. But the true scale of destruction would only become clear in the weeks, months, and years that followed. By then, the damage had rippled far beyond the impact zone, far beyond even the hemisphere where the asteroid struck. It was everywhere. No corner of the planet remained untouched. Entire species vanished. Not just the towering, iconic dinosaurs, but life in every form, in every habitat. In the oceans, massive reptiles like the plesiosaurs and mosasaurs, once rulers of the ancient seas, drifted lifeless in waters that no longer held enough oxygen or food to sustain them. Their sleek bodies, built for speed and power, meant nothing now. The currents that once carried them across entire continents now moved silently past empty coral beds and collapsing kelp forests. Above the waves, the sky had changed too. Where great pterosaurs once soared, gliding with wingspans larger than small planes, now there was only smoke and stillness. Their high nests had burned, their hatchlings had no warmth. With insects dying off and small prey becoming scarce, even the best adapted flyers eventually grew weak and fell. On land, the great dinosaurs, both predators and prey, were already disappearing. But they weren't alone. Tiny creatures, too, fell victim to the shifting world. Countless insect species, pollinators, scavengers, recyclers of life, died when the plants they depended on withered under blackened skies. Ferns, conifers, flowering shrubs, entire ecosystems of green collapsed as sunlight vanished, temperatures dropped, and photosynthesis halted. Seeds never sprouted, roots lost their grip, soil became lifeless dust. As the plant life died, so did those that depended on it. Small herbivores, reptiles, early mammals, birds struggled to find anything edible. They scratched through ash covered earth for buried tubers, dug into hollow logs, hoping for hidden fungus, chewed the bark off dying trees. But hunger only postponed the inevitable. For every creature that survived one more night, 10 others faded quietly into extinction. And extinction, this time, meant something massive. Roughly 3 out of every 4 species on Earth were gone. That's not 3 out of 4 animals in one area. That's 3 out of 4 types of life wiped out globally. From the insects in the trees, to the fish in the oceans, to the plants that once formed endless green canopies across continents, an estimated 75% of Earth's biodiversity vanished. In the fossil record, it's marked like a wound, an unmistakable line where abundance once was, and then suddenly wasn't. Paleontologists call it the KPG boundary, a thin layer of sediment found all around the world, in cliffsides, riverbeds, and deep sea cores. Within that layer, high levels of iridium, a rare element on Earth but common in asteroids, shocked quartz, minerals deformed by sudden intense pressure, spherical tektites, tiny droplets of molten rock that rained down and hardened as they fell. It's all there, fossilized in stone, proof of the day everything changed. This wasn't just the end of the dinosaurs. It was the end of the Cretaceous period, the final chapter of the Mesozoic era. An entire geological age closed in a geological instant. The planet didn't just lose large animals, it lost identities, relationships, entire ways of life. Predator-prey dynamics, reproductive cycles, migratory patterns, evolutionary trees, all snapped. The extinction was fast in geological terms, just a few thousand years, maybe less, but for the survivors, it felt slow, a long, drawn-out collapse, a quiet unraveling. Every day brought fewer sounds, fewer movements, fewer signs of life. It wasn't always dramatic. Many deaths happened in burrows, in nests, under leaves, in the hollows of logs. Creatures curled up and simply didn't wake. And yet, even as one world ended, the ground still held something new. Deep in the soil, some seeds managed to stay dormant. Spores waited in the shadows. Microbial life clung to warmth near volcanic vents. Somewhere in the underbrush, tiny mammals gave birth in silence. A new generation would come, but for now, Earth was grieving. The extinction wasn't just the absence of life. It was the weight of what had been lost, the scale, the variety, the beauty. Forests that once buzzed with insects were now still. Beaches where reptiles laid eggs now lay untouched. Mountains that echoed with calls and footsteps now stood in perfect, terrible silence. This was no mere disaster. This was transformation through annihilation. And yet, something remained. Something small. Something waiting. For a long time, the answer seemed simple. The asteroid came, the sky darkened, fire rained down. The dinosaurs, those massive thunderous beasts that had ruled the earth for over 150 million years, were gone, extinct, lost forever in the ash of the past. But the truth, as scientists would slowly uncover, is far more surprising, because while many of the dinosaurs vanished in the inferno and ice that followed the impact, not all of them were lost. A few changed, and in that transformation, they found a way to survive. It started with bones. In the years after the KPG extinction boundary was discovered, paleontologists began re examining fossils with fresh eyes. Not just the giant skeletons in museum halls, but the smaller ones, light, hollow boned creatures that had once flitted through the underbrush or darted between trees. Some of these bones showed strange features, wishbones, for instance, structures thought to be unique to birds. Then came the feathers. In places like Liaoning, China, a treasure trove of exquisitely preserved fossils began to emerge from ancient lake beds. These weren't just impressions of bones, but of full outlines, soft tissue, skin, and most startling of all, feathers. Long, branching, symmetrical feathers. Not simple fuzz, but flight ready plumes, and they were attached to unmistakably dinosaurian bodies, clawed arms, sharp teeth, long tails. Dinosaurs, real ones, had feathers. This wasn't just one exception, dozens, then hundreds of specimens followed, some with full wings, some with colorful crests, some with both scales and feathers. The more scientists looked, the more the line between bird and dinosaur blurred. It turned out that what we think of as birds today, sparrows, eagles, penguins, even chickens, are not separate from dinosaurs. They are dinosaurs. Specifically, they are part of a group known as theropods, the same branch that includes the fearsome Tyrannosaurus rex and the agile velociraptor. In evolutionary terms, birds are not distant cousins, they are direct descendants. Look closely, and the evidence is everywhere. Bird hips, shaped in a unique backward facing orientation, mirror those of small theropods. Their three toed feet, their flexible necks, their keeled breastbones for flight muscle attachment. Even their lungs, with air sacs extending into the bones for efficient breathing, resemble structures found in certain dinosaur fossils. And it's not just in the bones. Behavioral links shine through as well. Some non-avian dinosaurs built nests, laid eggs in organized clutches, and brooded over them, just like birds. Others showed signs of complex courtship rituals and social hierarchies, hinted at by display crests and group fossilizations. One of the most striking examples is the fossil of a small dinosaur called Microraptor. It had long feathers not only on its arms, but also on its legs and tail, forming a kind of four-winged glider. It couldn't fly quite like a bird, but it was close, an evolutionary stepping stone caught mid-transition between land-dwelling reptile and full-fledged flyer. All of this added up to a stunning realization. The age of dinosaurs didn't truly end, it changed form. When the world fell dark and the giants died, some small feathered dinosaurs, lightweight, fast, adaptable, managed to endure. Perhaps they had more flexible diets. Perhaps they could seek shelter in trees or burrows. Whatever the reason, they held on through the darkness. They made it through the cold, and when the skies began to clear, they spread their wings. The dinosaurs that ruled the earth are not just echoes in rock or bones in museums. They're alive today, chirping in trees, gliding over oceans, nesting under eaves. Every pigeon in the park, every falcon diving from a skyscraper, every bright parrot calling in the rainforest is living proof of survival through transformation. So did all dinosaurs die? Not quite. Their legacy didn't just survive, it soared, and while their giant cousins fell to fire and frost, The ones that took to the skies found a new world waiting, a quieter world, yes, but one full of opportunity. From the ashes of extinction, evolution wrote a new chapter, one feather at a time. In the thick of darkness, beneath the ash choked skies and the smoking forests, something stirred in the soil. Not a giant, not a hunter, but a survivor, small, furry, and alert. As dinosaurs fell and the planet convulsed with fire and ice, these creatures did what they had always done: scurried, dug, and adapted. They were mammals. At the time of the impact, mammals were nothing like the large dominant animals we know today. They were mostly tiny, no bigger than a squirrel or a rat. They had been living in the shadows of dinosaurs for over 100 million years, hiding in burrows, climbing through underbrush, or nesting in crevices. But that very obscurity may have saved them. Unlike the towering reptiles that required vast landscapes and abundant food, mammals didn't need much to survive. Their small size was a hidden advantage. Less food, less space, less exposure. In a world where giant creatures collapsed under the weight of hunger and heat, the tiny had a chance. But it wasn't just size. Mammals were warm-blooded, able to regulate their body temperature even as the world turned cold. As temperatures plummeted in the post-impact gloom, this ability became a lifeline. Reptiles and amphibians, dependent on external heat sources, struggled in the chill, but mammals, covered in fur and burning energy from within, could keep going. They could move, forage, flee, and shiver their way through nights that seemed to last forever. Then there was their diet. Mammals weren't picky. Some were insectivores, eating anything that crawled. Others gnawed on roots, seeds, fungi, and whatever organic matter remained. In a landscape stripped of lush vegetation and thriving prey, flexibility was key. While specialized dinosaurs starved when their food sources vanished, mammals simply shifted gears. They ate what was available: worms, rotting wood, even carrion if needed. Their teeth tell the story. Fossilized jaws from this period show a wide variety of tooth shapes: sharp points for catching insects, flat surfaces for grinding plant matter, and even jagged edges for chewing meat. This diversity allowed mammals to exploit niches left empty by extinction, carving out new survival paths in a collapsing ecosystem. But one of their most powerful tools wasn't physical at all. It was hidden deep inside, coded into their biology. Mammals reproduced quickly. While dinosaurs laid eggs and waited weeks or months for hatchlings, many mammals gave live birth. Their offspring developed inside their bodies, protected from the toxic world outside. And once born, those babies didn't need to fend for themselves right away. They were fed with milk, a nutrient-rich, warm, immune-boosting substance that came directly from the mother. No hunting required, no searching through ash for food. This parental care gave mammals a crucial edge. It wasn't just about surviving the moment, it was about raising the next generation, even when the world was broken. And they bred often. While a dinosaur might raise one or two broods in its lifetime, many mammals could produce several litters a year. That speed of reproduction meant that even if many died, a few could carry the torch forward. Generation after generation, they kept multiplying, even as the planet struggled to heal. Some mammals even burrowed deep into the ground, creating their own shelters. These tunnels offered insulation from the cold, protection from firestorms, and hiding places from predators. Beneath the surface, the soil held warmth, moisture, and sometimes even insects to eat. It was a world within a world, an underground sanctuary, while the surface burned and froze. And so, as the dust slowly began to settle, mammals emerged into a quieter earth. The dominant beasts of the past were gone. The skies no longer thundered with the wings of pterosaurs. The plains lay empty of horned titans, but the mammals endured, clawing, chewing, nursing and evolving. They didn't just inherit the Earth, they rebuilt it. From these early survivors would come new branches, marsupials, rodents, hoofed grazers, and eventually primates. And from those primates, through a slow and winding path of chance and change, would come us. But that part of the story hadn't begun yet. For now, it was enough that the mammals had lived. In a world reduced to silence, their tiny hearts still beat, and that heartbeat would echo into the future. As the skies dimmed and the ash settled over a wounded earth, the worst, it seemed, had already happened. The asteroid had struck, the fires had burned, the darkness had taken hold. But for some, the story wasn't over, because even after the Chicxulub impact had delivered its planet-shaking blow, the Earth wasn't done shaking. Beneath the crust, another disaster had already begun to rise, and this one came not from the sky, but from deep within the planet itself. Far across the globe, in what is now India, something ancient stirred. Hidden beneath layers of crust, a hot plume of molten rock had been building pressure for thousands of years. And now, in the aftermath of the impact, that pressure broke free. Volcanic fissures opened across the land like torn seams. Lava surged upward, not in brief bursts, but in floods, massive sheets of molten rock pouring across the surface in wave after wave. These were not ordinary eruptions, they were super eruptions, sustained over tens of thousands of years. This volcanic region became known as the Deccan Traps, named for the step-like layers of hardened lava they left behind, stacking mile upon mile across the Indian subcontinent. It's possible the asteroid's seismic shock waves helped trigger these eruptions, or at least accelerated them. Some scientists believe the timing was too close to be coincidence. The impact shook the planet like a bell. The crust flexed, fractured, and jolted, and deep below, the molten rock waiting to rise may have found its moment. The Deccan Traps release staggering volumes of lava, enough to cover an area nearly the size of modern France. But lava wasn't the only danger. With each eruption, enormous quantities of sulfur dioxide, carbon dioxide, and toxic gases belched into the atmosphere. These gases didn't come all at once, but in long, choking pulses. Each new release added another layer of harm to a biosphere already gasping for air. The sulfur dioxide formed sulfuric acid aerosols high in the sky, reflecting sunlight and driving global temperatures down even further. This prolonged the already devastating cold snap triggered by the asteroid. And when the sulfur finally settled out of the skies, the carbon dioxide remained, slowly rebuilding a greenhouse effect, but now trapping heat in a way that swung the planet to wild extremes. Cold and then hot, famine and then flood, a climate that couldn't make up its mind, devastating fragile recovery. But that wasn't the only invisible killer. As sunlight tried to return and the oceans warmed ever so slightly, new life forms began to bloom, but not the kind that brought stability. Instead, the warm, nutrient-rich waters birthed massive microbial blooms, swarms of bacteria that rapidly multiplied in the absence of a balanced ecosystem. These blooms devoured the remaining oxygen in the oceans, creating dead zones where nothing else could survive. Fish suffocated. Coral reefs, already weakened, collapsed entirely. The water turned cloudy and toxic in vast stretches, giving off noxious gases like hydrogen sulfide that could poison marine and even coastal life. These microbial surges may have delivered the final blow to species that had somehow clung to survival. Organisms battered by fire, darkness, and starvation now had to contend with oceans that choked rather than nurtured. The surface world was hostile, but the seas, once a refuge, became unrecognizable. And just when scientists thought they had pieced together this double punch of asteroid and volcano, Strange patterns in the fossil record raised new questions. In some layers of sediment, the die off seemed staggered, waves of extinction rather than a single event. In others, signs of recovery flickered briefly, only to vanish again. Something didn't add up. Was it possible that a third factor had slipped past our eyes, a hidden agent that made the difference between survival and annihilation? Some researchers have proposed that methane hydrates, frozen pockets of methane beneath the seafloor, may have destabilized in the warming aftermath, releasing potent greenhouse gases into the atmosphere and causing runaway climate shifts. Others wonder if Earth's magnetic field wobbled during this chaotic period, weakening its protection against cosmic radiation. Still others suggest solar activity, perhaps a brief cosmic event like a solar flare or gamma ray burst, added to the planetary chaos in subtle but destructive ways. Even now, millions of years later, the lines between these events remain blurred. The asteroid was clearly catastrophic, the Deccan Traps undeniably massive, the microbial blooms proven killers. But how exactly these events overlapped and whether they magnified each other's effects in a precise chain reaction remains a puzzle. What's clear is this: the end of the Cretaceous wasn't just a single bad day, it was a convergence of catastrophes, a storm of destruction from above, below, and within. And somewhere in the chaos, the ancient world lost its grip. But out of the ruins, something unexpected was preparing to rise. Long after the fires burned out and the skies cleared, Earth held on to the scars, and deep beneath the forests and oceans and deserts of today, those scars remain, layered into stone, like frozen echoes of a forgotten nightmare. For millions of years, this evidence lay untouched, sealed beneath sediment and time, until the quiet work of scientists began to unearth a truth so dramatic, so sudden, that it reshaped everything we thought we knew about extinction. The clue didn't come in a dramatic crater or a massive fossil. It came in something far smaller, something scattered thinly across the planet. A whisper in the rock, a line of dust. This line, found in rock layers on every continent, contains a rare element called iridium. On Earth's surface, iridium is incredibly scarce. It's locked away in the planet's core, rarely seen in large quantities above ground. But in meteorites and asteroids, especially those from the outer solar system, iridium is far more common. That's what made this global layer so strange. Why would a thin band of iridium-rich sediment show up in the exact same spot, right at the end of the Cretaceous period, in locations all over the world? Geologists first noticed the pattern in the 1980s. At dig sites in Italy, Denmark, New Zealand, and the United States, they found this narrow gray band, just a few centimeters thick, sandwiched between layers of older, fossil-rich rock and younger, barren sediment. Below the line, dinosaurs, ammonites, marine reptiles, life as it once was. Above it, silence, extinction, a whole world gone. That line, now famously known as the KPG boundary, marks one of the clearest dividing lines in Earth's geological history. And right in the center of that boundary, iridium tells a story of cosmic violence. But the iridium layer wasn't the only clue. Scattered across the same boundary layer were tiny glassy beads called tektites. These are not ordinary sediments, they're droplets of molten rock that were hurled into the air by an intense explosion, cooled while falling back to Earth, and solidified into smooth, curved shapes. They're born in moments of unimaginable heat and energy, and in this case, they were found not just near the Gulf of Mexico, but across Europe, Asia, and even as far away as Antarctica. This global spread made one thing clear: the event that created them wasn't local. It had to be something enormous, something capable of throwing molten Earth across entire hemispheres. Then came shocked quartz. Under a microscope, these grains of sand look almost ordinary until you see the internal fractures. These tiny parallel lines are only formed under extreme pressure, far greater than what any earthquake or volcano on Earth can produce. They are, however, a fingerprint of asteroid impacts. When geologists began finding shocked quartz mixed with the iridium and tektites embedded right in that thin boundary layer, they knew the pieces were connecting. A giant asteroid hadn't just hit the Earth, it had left a chemical, physical, and geological signature that was written into the very crust of the planet. And then, almost as if nature had left a calling card, the crater itself was found. Hidden beneath the Yucatán Peninsula in Mexico, the Chicxulub crater was identified by satellite imaging and confirmed by drilling. Measuring over 180 kilometers wide and more than 20 kilometers deep, it matched the size, age, and location needed to explain the global devastation. But what made the evidence undeniable was this: cores taken from the center of the crater showed the same iridium spike, the same melted rock, the same shocked minerals. It wasn't just a theory, it was a smoking gun. Still, the most haunting evidence wasn't in what was found, but in what was missing. In layer after layer of sediment, laid down over millions of years, there is a steady stream of fossilized life. Tiny shells, plant pollen, teeth, bones, all signs of a thriving, evolving world. But at the KPG boundary, that stream stops, instantly, not gradually. No slow fade, no transitional species, just a sharp, clean break. Dinosaurs vanish, ammonites disappear, coral reefs go silent, giant marine reptiles leave no trace beyond that line. It's as if someone turned off the lights on the entire planet, and that moment was captured in stone. And even now, every time scientists drill into Earth's crust or chip away at ancient cliffs, they keep finding that same line. It's in the badlands of Montana, the cliffs of Spain, the depths of the seafloor. Always the same ingredients, always the same date, always the same story. A global catastrophe that unfolded so fast and left so few survivors that it pressed itself into the very bones of the planet. And yet somehow, amid the soot and glass and ash, some life clung on. Long after the dust settled from the Chicxulub impact, long after the skies cleared and life began its slow, cautious return, the planet still turns beneath a sky full of possibilities, some beautiful, some terrifying. And hanging in the vast silence of space are countless rocks, remnants from the solar system's chaotic past, still on the move, still wandering, still watching. The question isn't whether the Earth will be struck again, it's when. Today, we live in an age where telescopes scan the heavens constantly. Automated systems monitor the skies night and day, tracking the movements of asteroids that drift near our planetary neighborhood. These objects are known as near-Earth objects, or NEOs. Some are only a few meters wide, others are hundreds of meters across, large enough to flatten cities, or worse. Every time one of these objects comes close, astronomers calculate its orbit, its speed, its trajectory. They give each one a designation, log its path, and check for potential future collisions. Thousands of these space rocks are now cataloged, and many are well-known companions of our orbit, sweeping past harmlessly year after year. But not all of them are easy to spot. Some approach from the direction of the sun, hiding in its glare until they're dangerously close. Others are too dark to reflect light, their carbon-rich surfaces blending into the blackness of space. Some move in unexpected ways, tugged by gravitational forces we didn't account for. And then there are those we simply haven't seen yet, lurking out there, waiting for a moment to cross Earth's path. That's why space agencies around the world remain uneasy. NASA, ESA, and other organizations have developed programs specifically designed to detect threats early. The Planetary Defense Coordination Office, for example, keeps a constant watch on incoming NEOs and releases alerts if any object gets too close for comfort. Satellites like NEOWISE and new proposed missions like NEO Surveyor aim to spot asteroids before they can surprise us. But knowing is not the same as stopping. Right now, Earth does not have a fully developed planetary defense system. We have concepts, ideas on paper, some tested in small scale experiments, but nothing yet capable of deflecting a large asteroid with certainty. One recent step forward came with NASA's DART mission, the Double Asteroid Redirection Test. In 2022, a spacecraft intentionally crashed into a small moon orbiting the asteroid Didymos, changing its path ever so slightly. It was a proof of concept, a demonstration that with enough warning, we might be able to nudge a threatening rock off course. But that test involved a relatively small object and plenty of warning. The Chicxulub asteroid would have needed something far more powerful, and we'd have to spot it years in advance to even have a chance. The danger isn't theoretical. We've already received warnings from the modern age. In 1908, in the remote forests of Siberia, a massive explosion flattened over 800 square miles of trees near the Tunguska River. No crater was found, leading scientists to believe the asteroid or comet disintegrated in the atmosphere, unleashing energy comparable to a modern nuclear bomb. If it had exploded over a city instead of wilderness, the death toll would have been catastrophic. More recently, in 2013, a smaller asteroid entered Earth's atmosphere over Chelyabinsk, Russia. This time, people saw it. Dash cams caught the brilliant fireball streaking across the sky. It exploded high above the ground, sending a powerful shock wave that shattered windows in thousands of buildings and injured over 1,500 people. And that asteroid was only about 20 meters wide. That's the terrifying part. These objects don't have to be mountain-sized to cause damage. A small one can level a city. A medium one can disrupt an entire continent. And a large one, like the one that ended the age of dinosaurs, could erase modern civilization in a single fiery hour. The Earth still bears the scars of its past impacts. Craters dot the planet's surface like faded bruises. Manicouagan in Canada, Vredefort in South Africa, Chicxulub in Mexico, each one a reminder that the cosmos does not play favorites, and that life on Earth is balanced on the edge of cosmic chance. Despite all our technology, all our knowledge, we are still vulnerable. We've conquered disease, split the atom, and sent probes to the edges of the solar system, but we have yet to fully solve the threat of rocks falling from the sky, and in the quiet darkness, they continue to orbit, patient and silent, watching, waiting, not out of malice, but because that's what gravity does. It moves things, it pulls, it collides, and we, small as we are, live in the space between those collisions, each day a borrowed miracle. The asteroid came from deep space, drawn silently toward Earth by the invisible hand of gravity. But what if, at the last moment, it had passed by just a few thousand miles wider? What if Chicxulub had missed? The Earth would have spun on, unscathed. No fireball, no shockwave, no mass extinction. The skies would have remained blue, the forests unburned, and the oceans undisturbed. And somewhere in a dense, humid jungle, a Tyrannosaurus rex might have torn through the underbrush in search of prey, unaware that fate had nearly erased its world. Without the impact, the Cretaceous period would have continued into a new chapter. The ecosystems, lush, vast, and finely balanced, would have thrived. Giant sauropods would still have thundered across the open plains, shaking the ground beneath their feet. Triceratops and ankylosaurs would have continued grazing in massive herds, while predatory beasts like Giganotosaurus and Velociraptor would have kept perfecting their deadly craft. Bird-like dinosaurs would still have flapped through the trees, their feathers used not just for flight, but for mating displays, warmth, and intimidation. But full-fledged mammals, as we know them, might have remained in the shadows, small, hidden, and cautious. Because the truth is, mammals were never the stars of the Mesozoic stage. They were side characters, mostly tiny nocturnal insect eaters living under logs or in burrows, dodging dinosaur feet and surviving by staying unnoticed. Without the asteroid's cataclysmic reset, that's likely where they would have remained. That includes us, the early mammals that eventually gave rise to primates and later to humans, might never have gotten the chance. With dinosaurs dominating every corner of land, sea, and sky, there may have been no evolutionary opening wide enough for large, intelligent mammals to emerge. No primates swinging from trees, no opposable thumbs, no fire, no language, no cities rising from the plains, no music echoing through cathedrals, no telescopes gazing back into the stars. Instead, Earth could have evolved into something far stranger. Imagine a parallel planet, teeming with life, but none of it human. A world ruled by advanced dinosaurs, creatures with larger brains, perhaps even more social behavior, evolving slowly over millions of years into something unrecognizably sentient. Some paleontologists have speculated that if certain lineages like the troodontids had continued to evolve, they might have developed intelligence comparable to apes or even beyond. Would they have developed tools, built fire, formed tribes? It's speculation, but not impossible. Evolution doesn't follow a script, it adapts to the world as it is. And in this alternate Earth, perhaps towering megapredators still rule the jungles, while smaller dinosaur species evolve elaborate social rituals, strange calls, and brilliant feathers in every hue. Forests echo with unfamiliar sounds. No pyramids rise from the desert. No great wall winds across the hills. No humans tell stories of gods or galaxies. The continents would shift in time, as they always have. Ice ages might come and go, but civilization, the kind built with stone, iron, and ideas, might never take root. Or if it did, it might look nothing like ours. Technology, language, even the shape of tools, if they existed, would be tailored to clawed fingers, taloned feet, and minds evolved along a very different path. In this world, perhaps there's no moon landing, but maybe there's a flying reptile with bioluminescent skin that glides silently under a canopy of alien-looking trees, completely unaware that in another version of Earth, a species once looked up and wondered, are we alone? It's humbling to think how close we came to never existing at all, because that asteroid didn't just wipe out the dinosaurs, it cleared the stage, it broke the old world and made room for a new one, a vacuum that evolution filled with warm-blooded creatures, adaptable and curious. Eventually, they would learn to shape stones, build fires, tell stories, and dream of things beyond themselves. But without that reset, without that random violent interruption from space, the world might have belonged to claws and teeth, not hands and voices. And so, as we look back at that one moment of cosmic roulette, it's hard not to wonder how many other Earths across time, across galaxies, missed their asteroids, or worse, how many still have one coming. In the chaos that followed the asteroid strike, the Earth seemed broken beyond repair. The skies darkened, the forests burned, and the oceans turned acidic. Giant creatures vanished almost overnight. But buried beneath that devastation was something unexpected, an opportunity, a strange, brutal kind of beginning. With the dominant species wiped from the land, a vacuum opened, a space in the ecosystem, once fiercely guarded by dinosaurs and their kin, was suddenly empty, and nature, as it always does, rushed to fill it. Small mammals, once relegated to the shadows, began to emerge. They'd survived the worst days, curled in burrows, hidden beneath leaf litter, feeding on anything they could scavenge. They were not mighty, they were not majestic, but they were alive, and more importantly, they were adaptable. These mammals didn't just inherit the earth, they slowly reshaped it. Without towering sauropods to graze the treetops, forests changed. Without predatory tyrannosaurs to patrol the plains, new kinds of danger and new kinds of freedom arose. The planet entered a strange quiet, filled with gaps in the food chain, unoccupied niches, and open evolutionary doors. In this transformed world, survival didn't belong to the biggest or strongest, it belonged to the clever, the quick, the flexible. Intelligence became a better tool than teeth, creativity more useful than size. Every generation brought new mutations, new chances for something unexpected to thrive. From this slow trickle of change, life began to rebuild itself. Tiny rodent like mammals diversified, radiating into forests, swamps, and grasslands. Some learned to climb trees, some to swim, others to glide. Over millions of years, this new wave of life evolved into everything from bats to whales to primates. Every species we know today, from cats to kangaroos to ourselves, can trace its lineage back to a handful of survivors that made it through the impact winter. Among them, early primates began to form. They had hands nimble enough to grip, eyes that could judge depth, and brains that were slowly growing more complex. In a world now driven by adaptation, their intelligence became their edge. They learned to cooperate, to care for young, to solve problems in ways no other animals could. Social groups formed, memories stretched longer. Over time, they began to understand patterns, seasons, dangers, opportunities. Their ancestors would evolve into apes, and from apes into something else entirely. It wasn't a straight path. Evolution isn't a staircase. It's a messy web of chance, struggle, and luck. But without the asteroid, that web may never have been woven this way. The extinction that ended one world was the spark that began another. It's easy to think of the Chicxulub impact as a disaster, and it was, but from that explosion of death came the conditions necessary for new forms of life to rise. The death of the giants created space for something small and thoughtful to grow, and intelligence, once just one trait among many, became one of evolution's most powerful tools. Eventually, those thinking creatures would look up at the stars, not with fear, but with wonder. They would build languages, societies, machines. They would explore oceans, climb mountains, and peer into the past through fossils and sediment layers. They would learn about the asteroid, not just as a myth, but as a fact, a turning point, a cosmic hammer that shattered the old world and scattered the seeds of the new. And they would realize that without it, they may never have existed at all. But the story didn't stop there, because as these new creatures built telescopes and satellites, they also began to ask questions that no dinosaur ever could. Questions like, could it happen again? And more urgently, if it did, would we survive? Smoke thickens the sky until day and night become indistinguishable. The sun, once blazing over the Cretaceous world, is now little more than a dim orange blur behind an endless veil of ash and heat. Trees that once towered over lush undergrowth have turned to blackened skeletons. The air tastes like burning metal. Amid this scorched wasteland, beneath a shallow overhang formed by a fallen tree and a ridge of crumbling rock, a mother dinosaur shelters with her young. She is a hadrosaur duck-billed, plant-eating, and once part of great herds that shook the ground when they moved. Now she is alone. Her flanks are streaked with soot, her breathing is shallow and ragged, but her body still curls protectively around her remaining eggs, shielding them from the heat that pulses across the ground like a fever. A distant thunder rumbles, not from the sky, but from the earth itself. Aftershocks still tremble through the crust like the planet is trying to shake off its pain. Every so often, the mother lifts her head, eyes wide, nostrils flaring, trying to sense if danger is closer than before. Each time she settles again, slower, weaker. Her instincts tell her to protect, but even her instincts are growing quiet now. Inside one of the eggs, there's movement. A small claw presses against the shell from within, then a crack, then another. Bit by bit, the tip of a beak emerges, followed by blinking eyes, confused, fragile, new to the world. A hatchling breaks through, slick with the remnants of its first breath of life. It chirps, softly at first, a weak, wavering sound that might have once drawn its siblings to huddle close, but there are no siblings anymore, just ash. The baby nestles into the crook of its mother's forelimb, nuzzling into the warmth of her body, but she doesn't move. Her breath has stopped, somewhere between the time the firestorm reached the treetops and the ground began to crack from the heat. Her skin is dusted with white flakes falling from the sky like snow, but searing hot. Still, the baby chirps again, louder this time, alone now. The sound vanishes into the silence, swallowed by the suffocating haze that presses down like a blanket on the ruined forest. A few feet away, the underbrush flickers. Embers, carried on the wind, dance across the ground, finding anything that can still burn. A fern curls into itself and vanishes in flame. Sparks drift dangerously close to the nest. The baby, barely able to walk, struggles onto unsteady legs. It doesn't yet know where to go. It only knows it must move, but there is nowhere left to run. The storm above breaks open with thunderless rage. Not rain, but more ash, more choking dust. The sky rains particles so fine they get into the eyes, the throat, the lungs. Even the most resilient creatures struggle to breathe. The hatchling wobbles a few steps forward, squeaking into the blackness, searching for something, anything familiar. It collapses beside a charred log. The forest is now a graveyard of shadows, with every twisted branch and scorched trunk whispering of what once was. Somewhere far beyond this quiet scene, other creatures are still trying to escape, but the world has already chosen what will stay and what will go. This baby will not see another morning, and neither will its kind. This imagined moment is just one of countless stories that unfolded in those final hours, a single spark in a world consumed by fire. Most will never be known. No fossil will capture a mother's final breath or a hatchling's last cry. But the earth remembers in its own way, in the layers of soot buried deep in ancient rock, in the chemical signatures of catastrophe, in the silence that followed. And as this silence settled across the earth, a strange kind of stillness began to grow, one that would, eventually, give rise to something new. Long after the cries fell silent and the ash settled over a ruined earth, time began its quiet work. Layer by layer, sediment blanketed the bodies of the fallen, ash turned to stone, forests that once towered high were buried, compressed into coal. Even the bones, those last fragile traces of the creatures that once ruled the world, sank into the earth's memory. It would take more than 66 million years for the silence to be broken. Now, with every fossil pulled from the rock, a whisper from that lost world returns. In cliffsides, quarries, deserts, and canyons, scientists uncover snapshots frozen in stone, skeletons tangled in death poses, nests turned to fossils, leaves singed by ancient firestorms. And what they find paints a picture not of a slow decline, but of an ending that came with shocking speed. Some of the clearest signs come from vast bone beds, places where dozens or even hundreds of animals died together. In the Hell Creek Formation of North America, for instance, Bones of triceratops, hadrosaurs, and theropods lie jumbled together, as though life simply stopped. No scavenger marks, no signs of decay, no slow disarticulation. It's as if the world pressed pause. These are not skeletons picked clean by time. They are graves created in moments. And when paleontologists examine the bones more closely, the message deepens. Inside fossilized bones, growth rings, like those in trees, show how animals lived through seasonal changes. But something strange happens near the very end of the Cretaceous. Many growth rings stop mid pattern, as if the cycle was interrupted, as if the year simply ended. These sudden halts in development aren't limited to one region. From Montana to Mongolia, from Argentina to Alberta, the fossil record echoes the same sharp silence. Whether the creature was massive like a T, Rex, or small like a burrowing mammal, the signs point to a shared catastrophe, something global, something final. Further down in the rock layers, a line barely thicker than a pencil marks a boundary, the KPG boundary. It's a thin band of clay that circles the planet, found in sediments from Europe to New Zealand, from Antarctica to the Middle East. In this narrow layer, geologists find particles of iridium, a rare metal more common in asteroids than in Earth's crust. It's the chemical fingerprint of the impact, a smoking gun. But the fossils do more than tell us how things ended. They hint at the chaos that followed. Just above the iridium layer, the diversity of fossils plummets. Coral reefs vanish. Ferns temporarily dominate, a phenomenon scientists call a fern spike, because ferns, hardy and fast growing, were among the first to recolonize burned landscapes. Mammals become more common, but the kinds that appear are tiny, scrappy survivors. Almost nothing that existed before the boundary looks the same after it. Even the ocean floor keeps secrets. Core samples taken from deep beneath the seabed reveal mass extinctions of plankton, tiny organisms that form the base of the marine food chain. Species that had thrived for millions of years disappear abruptly, replaced by smaller, simpler forms that could tolerate the dark, acidic water. Microscopic fossils tell the same story as the giant bones above them. The world changed almost overnight. Fossil pollen and spores from plants also testify to the devastation. Before the impact, forests teemed with flowering plants, cycads and conifers, but in the layers directly above the boundary, most of those vanish. Instead, spores from fungi and mold dominate, a sign that the world, once green and lush, had become a giant compost pile. Dead things outnumbered the living. Still, the fossils are not just evidence of death. They are records of resilience. Within the destruction, scientists can trace how life began to recover. New species emerge, new forms, new possibilities. But those stories live in the layers that come later. In the rock, time is measured not in hours or days, but in millimeters of sediment and the bones entombed within it. And each fossil, no matter how small, helps piece together the puzzle of what happened during that one terrible day when the dinosaurs died. But life, somehow, did not. From charred plant impressions to perfectly preserved skeletons curled in final rest, the earth continues to speak. And those who dig, who study, who listen closely, are learning to read the story etched in stone. Extinction is not just about death, it's about what comes after. Because what truly lingers isn't just the silence of those lost species, but the echoes of what they left behind. The empty forests that once thundered with footsteps now stand quiet, but in that stillness, something new began. After all the heat, the darkness, the hunger, came opportunity. In the shadows of giants, tiny survivors emerged, fragile, trembling, but alive. One asteroid didn't just destroy the dinosaurs, it changed the path of life forever. That moment, frozen in geological time, didn't just close a chapter, it opened the door to everything that came next. Mammals, primates, humans, us, you. And maybe that's the strangest part of all. We exist because they don't. Our rise is written in the ashes of their fall. But if you've made it to this point in the story, still here, still watching, then you understand that this isn't just a tale of ancient beasts. It's a mirror held up to today. Because those warning signs, they're not buried in the past. They're still out there, gliding through the darkness beyond the moon, orbiting silently through the void. Near Earth objects, big ones, small ones, fast ones, are tracked by our telescopes every day. We've spotted thousands, and we've missed some too. The asteroid that hit Chelyabinsk in 2013 came without warning. No countdown, no defense, just sky, then fire. And Tunguska, it flattened over 800 square miles of forest. If it had hit a city, the aftermath would have looked disturbingly familiar. That's why this isn't just about dinosaurs. It's about us, what we've learned, what we've forgotten, what we're still not prepared for. So here's where you come in. If this journey through the dinosaurs' final day moved you, if you felt the tremble of the earth, the rain of fire, the quiet after the storm, then let it live on. Tap that like button, subscribe to the channel for more stories that bring science to life, and in the comments, leave the words, "I survived the asteroid." Let's see who else made it through the chaos, the fire, the winter, and the rebirth. But before we go, one more question lingers, one final spark of imagination to carry into the night. If the dinosaurs had one last thought, what was it? Was it fear, confusion, regret, or something simpler, like the instinct to protect a hatchling or the longing to see the sun rise one more time? We'll never know for sure, but maybe, just maybe, that thought didn't vanish. Maybe it traveled forward, echoing through time until it found you. And now the question turns, are we ready if it happens again? Because history doesn't just live in textbooks. Sometimes it comes roaring back with no warning. So the next time you look up at the stars, remember what they've already done and ask yourself, is this where the story ends or where the next one begins?